Now, to start off with, what exactly is artificial intelligence? Artificial intelligence is a science that empowers computers to mimic human intelligence, such as decision making, text processing, and visual perception. Artificial intelligence is a broader field, as you can see in the picture, the big umbrella that contains several subfields such as machine learning, deep learning, and a couple of other components such as robotics and computer vision. Now moving on to machine learning. Machine learning is a subfield of artificial intelligence that enables machines to improve at a given task with experience. It is important to note that all machine learning techniques are classified as artificial intelligence. However, not all artificial intelligence could count as machine learning, since some rule-based engines could be classified as AI, but they do not learn from experience. Therefore, they do not belong to the machine learning category. Moving on to deep learning. Deep learning is a specialized field of machine learning that relies on training of deep artificial neural networks, in short form called as ANNs, using a large data set such as images or text. Artificial neural networks are information processing models inspired by the human brain. The human brain consists of billions of neurons that communicate to each other using electrical and chemical signals and enable humans to see, feel, and make decisions. ANNs work by mathematically mimicking the human brain and connecting multiple artificial neurons in a multi-layered fashion. The more hidden layers added to the network, the deeper the network gets. Now, deep learning will be covered in depth in the deep learning course. Now, let's dive deep into the machine learning. Now, let's try to understand the different types of machine learning. As you saw in the previous slide, that machine learning is a subset of AI which enables machine to improve at tasks with experience. Now, there are basically three types of machine learning. I'll be taking you through all the three types, starting off with the supervised learning. So in supervised learning, the training algorithms has the labeled input bar output data. And in supervised learning, there are two different types. One is classification and regression. So as we move ahead, I will go in deep what exactly is a classification and regression in separate. Second one is the unsupervised learning. Here, the training algorithms have no labeled data. And inside this, there's only one type, that is clustering. So there are various clustering techniques. So I'll be taking you through it at the later stages. Third one is the reinforcement learning. Here, the algorithms take actions to maximize cumulative reward. So suppose, for example, if we have a robot and if you are trying to teach the robot to move in a proper way, so robot is in contact with the environment. If the robot is taking wrong decisions when it's performing its task, then we penalize the robot. All right, so if the robot is moving on with the correct path, we reward the robot with plus points. So more the number of rewards, the robot understands that it is taking the right decision. All right, so these are the different three types of machine learning, that is supervised, unsupervised, and reinforcement learning. I'll be taking you through the supervised learning and its type, unsupervised learning and its type in the consecutive videos. Now, as we saw that deep learning was a subset of machine learning, but what makes it different from machine learning? Like, what's the difference between a machine learning and a deep learning? As you can see in the first diagram, we have a couple of images with cat, and you can see the second block, that is a manual feature extraction which is happening. So manually the features of a cat, the face features, for example, the eyes, the way the nose, the whiskers of the cat, and then the ears, the how the ears are structured. So all these features are extracted manually in a machine learning, and then we run a classification algorithm to check whether the image is of a cat, dog, or a mouse. But when you look at the second picture, that is with respect to deep learning, you can see that we take the images directly and we pump it to the convolutional neural network. All right, so as I told you that deep learning is trying to mimic the human brain. All right, so here there is no manual feature extraction. Features are extracted and learned by the neural network automatically. So that is what makes a huge difference between the machine learning and deep learning. That in machine learning, manual feature extraction takes place, but in deep learning, everything is learned by itself. And then finally, again, the output is whether the picture was of a cat, dog, or a mouse. Now, let's try to understand why machine learning is the future. What is the reason behind studying machine learning and how machine learning is going to be the future? Alright, so here we have got a cloud and it just illustrates that data is everywhere. We presently live in 21st century and wherever you go there is data. Whether you are sending a text message, you're updating your status in Facebook, Instagram, or you are constantly updating your live location using GPS. Each and every one of this is generating a huge amount of data. This data is growing exponentially. It's just cumulative all the time. From the dawn till 2005, humans have generated 130 exabytes of data. Now let's see how this has been happening throughout the history of human mankind. Now you might be thinking 130 exabytes of data sounds very cool, but it is very hard to imagine what an exabyte is all about. Now let's try to understand what an exabyte is all about. Now here we get a letter A. Now letter A is a single letter and a single letter on computer takes 1 byte of data. Now, if we zoom out 1,000 times, we have 1,000 letters and 1,000 letters represents a page on a book that fits into 1 kilobyte. Now, if we zoom out another 1,000 times, we have 1,000 kilobytes, which is 1 megabyte. That is about a book of 500 pages, double-sided. Now, if we zoom out another 1,000 times, we get a gigabyte. Believe it or not, you can fit a human genome onto 1 gigabyte. If we zoom out another 1,000 times and we get 1 terabyte. And now if you take an HD camera and you walk around a person his whole life, every minute, every second of their life, and you film everything they do and you put all of that in a HD video, that will fit into 1 terabyte. Now zooming out another 1,000 times, as you can see in the picture, we have got the Amazon rainforest. It has about 1.4 billion acres of trees. Every acre has roughly around 500 trees in it. That makes around 700 billion trees in Amazon forest. Hypothetically speaking, if you chop all the trees, make paper out of it, and fill each and every page with letters or text, then you will get around 1 to 2 petabyte of data. When you zoom out another 1,000 times, that's when you get an exabyte. Exabyte is 1,000 petabyte. From dawn of time till 2005, humans had already created 130 exabytes of data. Now this includes words spoken, books written, films shooted, songs sang, and many more. And as you can see, from 2005 to 2010, the data has been increased from 130 to 1,200 exabytes. And then again adding 5 more years, so 2015, we have 7,900 exabytes. Adding 5 more years and coming to 2020, estimated to be 40,900 exabytes. This indicates the growth of data, and if you visualize it, it looks something like this. As you can see in the graph, this is the reality that we live in. You can see how quickly the data is growing every single year. So this was an actual study done by IDC sponsored by EMC. Machine learning is the potential to use a huge amount of data that is being generated and take up useful decisions on it. Now let's see how machine learning is applied in day-to-day life. Facebook facial recognition. Everybody knows this. When you upload a photo, Facebook somehow knows already who your friends are and tags them automatically. Well, that's a machine learning algorithm in action. Now, body-based action games. where you can play games without a joystick or any console. This uses random forest algorithm, which is a machine learning concept for its working. Then comes the virtual reality. Virtual reality headset where you turn your head and picture moves. How does the machine know which picture to show? Well, that's a machine learning algorithm, monitoring your actions and connecting them to the game or whatever you're looking at. Speech to text voice recognition. Now, in speech to text voice recognition module, ML plays a significant role. And then we have got some robot dogs. They learn how to walk, and it's very interesting how to teach them walk. They actually use machine learning method called reinforcement learning to learn. Facebook ads. The ads related to your search are shown to you. This is a recommender system which is driven by machine learning algorithm along with Facebook ads. Even Netflix and Audible, they use the recommender system, and machine learning is working in the back end. Machine learning is also used in medicine, which is used to detect cancer tumors by analyzing the images. Machine learning is also used in space. Machine learning is used in space to recognize areas of the world through maps. Machine learning is also used to explore new territory such as Mars, and machine learning algorithms are working in the back end of rovers. So this was all about the applications of machine learning. I hope you all are excited to begin your journey with the machine learning and to learn a lot in this course. I'll catch you in the next lecture. Thank you.